extended observations was to establish the important truth that each stratum contains certain fossils which are peculiar to it, and that the order in which the strata, characterized by these fossils, are superimposed one upon the other is always the same. This most important generalization was rapidly verified and extended to all parts of the world accessible to geologists. And now it rests upon such an immense mass of observations as to be one of the best established truths of natural science. To the geologist, the discovery was of infinite importance, as it enabled him to identify rocks of the same relative age, however their continuity might be interrupted or their composition altered. But to the biologist it had a still deeper meaning, for it demonstrated that, throughout the prodigious duration of time registered by the fossiliferous rocks, the living population of the earth had undergone continual changes, not merely by the extinction of a certain number of the species which had at first existed, but by the continual generation of new species, and the no less constant extinction of old ones. Thus the broad outlines of palaeontology, in so far as it is the common property of both the geologist and the biologist, were marked out at the close of the last century. In tracing its subsequent progress, I must confine myself to the province of biology, and indeed to the influence of palaeontology upon zoological morphology. And I accept this limitation the more willingly, as the no less important topic of the bearing of geology and of palaeontology upon distribution has been luminously treated in the address of the President of the Geographical Section. The succession of the species of animals and plants in time being established, the first question which the zoologist or the botanist had to ask himself was, what is the relation of these successive species one to another? And is it a curious circumstance that the most important event in the history of palaeontology, which immediately succeeded William Smith's generalization, was a discovery which, could it have been rightly appreciated at the time, would have gone far towards suggesting the answer, which was in fact delayed for more than half a century. I refer to Cuvier's investigation of the mammalian fossils yielded by the quarries in the older tertiary rocks of Montmartre, among the chief results of which was the bringing to light of two genera of extinct hoofed quadrupeds, the Anoplotherium and the Palaeotherium. The rich materials at Cuvier's disposition enabled him to obtain a full knowledge of the osteology and of the dentition of these two forms, and consequently to compare their structure critically with that of existing hoofed animals. The effect of this comparison was to prove that the Anoplotherium, though it presented many points of resemblance with the pigs on the one hand and with the ruminants on the other, differed from both to such an extent that it could find a place in neither group. In fact, it held in some respects an intermediate position, tending to bridge over the interval between these two groups, which in the existing fauna are so distinct. In the same way, the Palaeotherium tended to connect forms so different as the tapir, the rhinoceros, and the horse. Subsequent investigations have brought to light a variety of facts of the same order, the most curious and striking of which are those which prove the existence, in the Mesozoic epoch, of a series of forms intermediate between birds and reptiles, two classes of vertebrate animals which at present appear to be more widely separated than any others. Yet the interval between them is completely filled, in the Mesozoic fauna, by birds which have reptilian characters on the one side, and reptiles which have ornithic characters on the other. So again, while the group of fishes termed ganoids is at the present time so distinct from that of the dipnoi or mudfishes that they have been reckoned as distinct orders, the Devonian strata present us with forms of which it is impossible to say with certainty whether they are dipnoi or whether they are ganoids. Agassiz's long and elaborate researches upon fossil fishes, published between 1833 and 1842, led him to suggest the existence of another kind of relation between ancient and modern forms of life. He observed that the oldest fishes present many characters which recall the embryonic conditions of existing fishes, and that, not only among fishes, but in several groups of the invertebrata, which have a long palaeontological history, the latest forms are more modified, more specialized than the earlier. The fact that the dentition of the older tertiary ungulate and carnivorous mammals is always complete, noticed by Professor Owen, illustrated the same generalization. Another no less suggestive observation was made by Mr. Darwin, whose personal investigations during the voyage of the Beagle led him to remark upon the singular fact that the fauna, which immediately precedes that at present existing in any geographical province of distribution, presents the same peculiarities as its successor. Thus, in South America and in Australia, the later tertiary or quaternary fossils show that the fauna which immediately preceded that of the present day was, in the one case, as much characterized by edentates, and in the other by marsupials, as it is now, although the species of the older are largely different from those of the newer fauna. However clearly these indications might point in one direction, the question of the exact relation of the successive forms of animal and vegetable life could be satisfactorily settled only in one way, namely, by comparing, stage by stage, the series of forms presented by one and the same type throughout a long space of time. Within the last few years this has been done fully in the case of the horse, less completely in the case of the other principal types of the ungulata and of the carnivora. And all these investigations tend to one general result, namely, that in any given series, the successive members of that series present a gradually increasing specialization of structure. That is to say, if any such mammal at present existing has specially modified and reduced limbs or dentition and complicated brain, its predecessors in time show less and less modification and reduction in limbs and teeth, and a less highly developed brain. The labors of Gaudry, Marsh, and Cope furnish abundant illustrations of this law from the marvelous fossil wealth of Pikermi and the vast uninterrupted series of tertiary rocks in the territories of North America. I will now sum up the results of this sketch of the rise and progress of palaeontology. The whole fabric of palaeontology is based upon two propositions. The first is that fossils are the remains of animals and plants. The second is that the stratified rocks in which they are found are sedimentary deposits, and each of these propositions is founded upon the same axiom, that like effects imply like causes. If there is any cause competent to produce a fossil stem, or shell, or bone, except a living being, then palaeontology has no foundation. If the stratification of the rocks is not the effect of such causes as at present produce stratification, we have no means of judging of the duration of past time, or of the order in which the forms of life have succeeded one another. But if these two propositions are granted, there is no escape, as it appears to me, from three very important conclusions. The first is that living matter has existed upon the earth for a vast length of time, certainly for millions of years. The second is that, during this lapse of time, the forms of living matter have undergone repeated changes, the effect of which has been that the animal and vegetable population, at any period of the earth's history, contains certain species which did not exist at some antecedent period, and others which ceased to exist at some subsequent period. The third is that, in the case of many groups of mammals and some of reptiles, in which one type can be followed through a considerable extent of geological time, the series of different forms by which the type is represented, at successive intervals of this time, is exactly such as it would be if they had been produced by the gradual modification of the earliest forms of the series. These are facts of the history of the earth guaranteed by as good evidence as any facts in civil history. Hitherto I have kept carefully clear of all the hypotheses to which men have at various times endeavoured to fit the facts of palaeontology, or by which they have endeavoured to connect as many of these facts as they happen to be acquainted with. I do not think it would be a profitable employment of our time to discuss conceptions which doubtless have had their justification and even their use, but which are now obviously incompatible with the well ascertained truths of palaeontology. At present these truths leave room for only two hypotheses. The first is that, in the course of the history of the earth, innumerable species of animals and plants have come into existence, independently of one another, innumerable times. This, of course, implies either that spontaneous generation on the most astounding scale, and of animals such as horses and elephants, has been going on as a natural process through all the time recorded by the fossiliferous rocks, or it necessitates the belief in innumerable acts of creation repeated innumerable times. The other hypothesis is that the successive species of animals and plants have arisen, the latter by the gradual modification of the earlier. This is the hypothesis of evolution, and the palaeontological discoveries of